All right, y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for this one, we're going to do a remove, replace, reduce, where we remove that 5, and we multiply it by the 4. And then when we factor, you got to make sure you put the 5 back. And the two numbers you're going to want to use are -4 and -5. This first one is not going to reduce. The second one is going to become x squared minus 1. Now on this one, x squared minus 1 will actually factor further. So we have 5x squared minus 4, and then we're going to have x minus 1 times x plus 1. And so that would be your answer for this factoring question. For the math knowledge question, we have an isosceles triangle, and it says the base angle is twice the vertex angle. So this is our vertex angle. So the base angles are each twice the vertex angle. So that means that we have 5x equals 180. So x equals 36. So what is the measure of the base angle? Well, the base angle here is 2 times x. So 2 times 36 is 72. So that would be your answer for your math knowledge question. So we're looking at lesson 105 today. We skipped lesson 104. It's dealing with sequences and series, which I told you we were going to skip. So we are going straight to lesson 105. We're looking at cofactors and then expansion by cofactors. So this is going to be dealing with some matrices, and hopefully you'll understand how you use cofactors after this lesson. So the advantage of your cofactors is that it can be used to find the determinants of square matrices of any size. So it doesn't have to be a 2 by 2 or a 3 by 3. It can be any size. And the way that you do that, you break it down into expressions which contain smaller square matrices, which then you would break down into smaller square matrices, which you could break down into smaller square matrices until you're down to a 2 by 2. Okay? So that's what cofactors is good for. You can use them on any square matrix, doesn't matter the size. When we cross out the row and the column of an entry, we call the smaller determinant that results the minor of the entry. So if I have a matrix here, and I'm just going to do a 3 by 3. I'm going to cross out a row and a column. And so the numbers that are left are 4, 7, 6, and 9. And that is called the minor of the entry. Okay? So the numbers that are left are your minor of the entry. If you affix the proper sign to your minor, the combination of the two is called the cofactor of the element. Okay, so if you have the proper sign appended to the minor, then you're going to have your cofactor. The way you get the sign is from this matrix of the cofactor signs. I think it looks kind of pretty. Makes me think of snow, especially during the winter. Makes me think of snow. But basically, you start with the top left as a positive, and then you alternate positive, negative, and so you would just keep going if you had a bigger matrix, which we're not going to this year, but that's what you would do. Positive on the top left, and then you just continue to alternate. So we're going to find the cofactor of 7 in the following determinant. So we need to cross out both the row and the column that the 7 is in. So we cross out the top row and the middle column. And the numbers that are left are 2, 2, 6, and 5. Now all we need, that is our minor. All we need to add to our minor is the sign. Well, the 4 has a positive, the 7 is a negative because it comes next. And so that would be our cofactor for that determinant. Okay? So now, the value of the determinant can be found by summing the products of the elements in any row or column with their respective cofactors. Okay? So you can actually find the determinant of any matrix by summing the product of the element in any row or column with their respective cofactors. So we're going to look at an example. We're going to use cofactors to evaluate this determinant. So we need to pick any of the 3 rows or any of the 3 columns. The book picks the 3rd row. They're going to use the -1, 2, and -3 at the bottom. So I'm going to pick something else so that you can see, if you want, how they do it and how they get the same answer, even though they use different cofactors. So I'm going to use the 1st row here. So the first thing I need to do is to cross out the -4 in its row and column. And so I'm left with 3, -2, 2, -3. So that's my minor. Now I need to put the sign that goes with it, which is a positive, and I multiply it by -4 because that's the number that I crossed out. That's the number that was right here. Okay, so we're going to take our cofactor and multiply it by the -4, and we're going to have to do the same thing with the 2 and the 1. So I'm going to cross out the column and the row that the 2 is in, and I'm left with 1, -2, -1, and 3. And then is this a positive or a negative sign that I'm going to put here? It's going to be a negative, and I'm going to multiply it by 2 because that's the number that I was crossing out. Okay, so now we're going to do it one more time for the 1. Cross out the column and the row that the 1 is in, and I'm left with 1, 3, -1, and 2. It's going to be a positive, and I'm multiplying it by 1 because that's what that number is. Okay, so again, you could use any row or any column. So there are technically 6 different ways that you could set this up, but you'll get the same answer any way you do it. So now what we do, we actually find the determinant here. So we have -4, we have -9 minus a -4, and we have -2, -3 minus 2, plus 1 times 2 minus a -3. And so now I have -4 times -5 minus 2 times -5 plus 1 times 5. So now I have 20 plus 10 plus 5, which if you add those together gives you 35. And so that would be the determinant for this matrix. If you look in the book, they did set it up differently, so if y'all want to pause and y'all want to look in the book at how they did it using a different row, you can. Okay? Looking at the next example, we're going to use cofactors to evaluate this determinant. Now, if you notice, that bottom left number is a 0. It's always good to use a 0 if you can, because it makes it a lot quicker on your math. So I'm going to choose to use a column this time. I'm going to use the first column. So I'm going to start with the -3, and then I'm going to have -3, -4, 4, and -5. And the number that goes with it is a positive, because it is the top left one. Now I'm going to go to the 2, and I'm going to cross out its row and column. And I'm left with 1, 2, 4, and -5. And the number, or the sign that goes in front of the 2 is a negative, because we always alternate positive to negative. And then the last one, I have a 0. And so I have 1, 2, -3, and -4. And the sign that goes with it is a positive, because again, you alternate. So the -3 was positive, the 2 was negative, and then this 0 was positive. Now, if you notice, this whole term is going to actually go to 0. So we don't even have to multiply or do anything with that determinant. We can just ignore it, because it actually goes to 0 because it gets multiplied by 0. So we have -3, and then 15 minus a -16, and then -2, -5 minus an 8 here. So I have negative 3 times 31, and then negative 2 times negative 13. So 3 times 31 is negative 93, and then plus 26, which should give you a negative 67. And so that would be your answer for that question. So again, I picked a row or column that had a 0 because I find that it helps make it go a little bit quicker, but you don't have to. No matter which row or column you use, you should still get the same negative 67. Okay? So let's look at one more. We want to use cofactors to evaluate this determinant. So I'm going to use the bottom row this time. So I'm going to start with the 1. I'm going to have 1, 2, negative 3, and negative 4. And that's going to be a positive, because this is positive, negative, positive. And then if I use the 4, we are going to have negative 3, 2, 2, negative 4. And it's going to be a negative that goes in front of it. And then I'm not even going to have to write the last one, because the last one is a 0. Okay? I'll show you what it would be, just in case you're still not sure on how to set that up. But we don't need it because it is just 0. So we have 1 times negative 4 plus 6 minus 4, and then 12 minus 4. And then you have negative 2, positive 2 minus 4 times 8. So that's 2 minus 32, which will give you a negative 30 for your answer. So if you would like, you can practice those with any row or any column that you want, but you should still come up with the same answer. Okay? So that's how you use cofactors, and you would do that for a 4 by 4, 5 by 5, etc. And you would just keep going until you ended where you had a 2 by 2 matrix that you can actually evaluate. You do get to omit number 1, 9, 10, and 16 on your homework. So make sure that you do that tonight so we can go over any questions you have tomorrow.